Imagine a massive earthquake strikes. The power grid fails. Cell towers go dark. Emergency responders are blind. And traditional communication is completely wiped out. How do you coordinate a rescue mission when you can't even send a text? You look up. A fleet of autonomous drones enter the airspace. They don't connect to cell towers. They connect to each other, creating a spontaneous flying internet. This isn't sci-fi. Welcome to the world of FANETS. FANETS stands for Flying Ad Hoc Network. In regular English, it's a network composed entirely of unmanned aerial vehicles, or drones, that talk to each other in mid-air without needing any ground infrastructure. You have probably learned of his airbound siblings, manets, which are mobile devices on the ground, and banets, which connect smart cars on highways. But FANETS take the concept to the third dimension. By using a mesh network topology, these drones share the load. If drone A is too far from the rescue team on the ground, it simply bounces its thermal camera feed to drone B, which passes it down the line. As long as one drone can see the ground station, the whole fleet stays connected. Building a flying internet sounds awesome, right? But it's an absolute nightmare for network engineers. Why? Because drones move fast. In a FANET, the network map changes every single second. If a drone turns a sharp object, its signal might drop. If a battery dries, a critical node vanishes. The network has to be incredibly smart. It has to self-heal instantly, rerouting data to the fly before the video feeds cut out. On top of that, drones are limited by battery life and processing power. Engineers have to write ultra-efficient algorithms so the drones don't waste all the energy just trying to talk to each other than actually flying. But when it works, it changes everything. In agriculture, FANETs allow a swarm of cheap drones to map thousands of acres of crops in minutes, sharing data to spot disease instantly. In military defense, they provide seamless surveillance without relying on vulnerable satellite links. And in remote areas, they can act as temporary flying hotspots, bringing internet to communities cut off by geography or disaster. Let's discuss some real-life examples. Take for example the Alps. When avalanches strike, mountains completely block traditional radio signals. To fight this, Professor Lorenzo Marconi and the European rescue teams launched the SERPA project. They developed a drone swarm where smaller drones dive into deep ravines to spot missing skiers, hoping their data peer-to-peer through the sky to beam life-saving coordinates back to the rescuers. Another example is deep in the Amazons, where there is cellular coverage. Giovanni Amanti's team of Exmobots collaborated with the Brazilian firefighters so that they use a FANET of long endurance drones to fly blinding through the thick smoke. By sharing thermal imaging data mid-air, the swarm creates a live decentralized map of moving wildfires, keeping ground crews safe. As artificial intelligence advances and batteries get lighter, FANETs will become a permanent feature of our skies. They are transforming drones from isolated gadgets into a collective, intelligent cloud in the sky. Next time you look up and see a drone, remember, it might be just one piece of the future of human connection. Thanks for watching.